On page 105, we have two examples where we're going to solve radical equations, and go after we just finished page 104. So we've got an equation which involves a radical where we have to solve for x. In other words, what are the values for x that make this equation true? And there are two examples on this page, and we're going to go over them. So let's start with example 1. And here we have the equation we're trying to solve for. And we isolate the radical first of all. Here's the radical right here. And we transpose the minus x from the left to the right. That's all we're doing. Now, the reason we do this, as I stated on the discussion on page 104, one could square this side here and then square that side. But it becomes a lot more complicated in terms of the algebra. So what we do is we isolate the radical sign and then to use the squaring property. So we don't square first. We isolate the radical. In this case, the radical contains the unknown. We transpose the minus x from the left to the right, and now we're going to square both sides. So we have the root of 2x plus 10 all squared, which works out to 2x plus 10. We square the x plus 1, we get x plus 1 squared, and that, of course, is the first times the first gives us x squared. The inner is 1x, the outer is 1x, both positive. We sum, they come 2x, and the last times the last becomes this one over here. Now you can see that what happens is something neat happens. We got 2x on the left and 2x on the right, so we could just cancel them. There is no x term. If you want, you could bring the 2x from the right to the left, but essentially what we're going to do is just cancel the 2x here, because they'll sum to 0. And we bring the 10 from the left to the right. We minus 10 plus 1, we get x squared minus 9. Now this is the difference of squares. We can factor this as x plus 3, x minus 3 equals 0. So we have two solutions, x minus 3 and x equal to plus 3. Now we have to go back and put the two values back into the original equation. Here we put the two values back in. So let's start with x minus 3. 2 times minus 3 plus 10. So we have 2 times minus 3 plus 10. And then here we have minus 3, because there's a minus because of this minus. And then the x itself is minus 3. So this becomes plus 3. So 2 times minus 3 is minus 6 plus 10 is the square root of 4. We get 4 plus 3. 2 plus 3 is 5. And so we work all this on this side is the left side, but the right side is 1. So this is untrue. So the solution of minus 3 doesn't work, and we call that an extraneous solution. Let's try the solution x equals plus 3. Put it back into this equation. What do we get? 2 times 3 plus 10. 2 times 3 plus 10. And then minus x is minus 3. 2 times 3 plus 10 sums to 16. The square root of 16 is 4. 4 minus 3 is 1. And the right side of the equation is 1. So 3 is a valid solution, and minus 3 is called an extraneous solution. Now, here again, if we go to problem number 2, sorry, we go to problem number 2. I lost my red dot here. Okay, we go to problem number 2. You'll see here we have two radical signs. So what we're going to do is put 1 on one side and 1 on the other side. Again, if we try to square this, it would be very, very difficult. So what we're going to do is isolate a radical. And so it doesn't matter if you want to put the x, square root x here and the 2x over 1 here, or just put the 1 on another side. It's okay. Doesn't matter. So what we're doing is moving this from the left to the right. We're isolating a radical. Now we square the left side, and now we square the right side. Now notice we have to put a bracket around this whole thing when we square it, because it sums first and then it squares. It sums first and then it squares. So 2x plus 1 squared gives us 2x plus 1. Now the first times the first gives us x. The last times the last gives us 1. The middle is the square root of x plus the square root of x. The inner is the square root of x, and the outer is the square root of x. When we sum, we get 2 root x. So you can see here we have a bit of a dilemma because we still have the root sign. So anyway, what we do is we bring the x from the right to the left. 2x minus x gives me x. The 1's cancel. They sum to 0. So we just drop this one and that one. So essentially what we're doing is just moving this x from the right to the left, and we get x equals 2 root x. Now we square both sides again. That's why it says repeat. So we square this one, we get x squared. We square this whole term. 2 times 2 is 4. And the root of x times the root of x is x. So we get 4x. We're squaring both sides. 2 times 2 is 4. The root of x times the root of x is x. Now we transpose this from the right side to the left, factor out the x, and we get 2 solutions, x equals 0 and x equals 4. So we go back into the original equation, and we get, let's start with the 0. 2 times 0 plus 1 minus the square root of 0. So you can see here you got to get the square root of 1 minus 0, and 1 equals 1. So that one works. Now if you try the other term in here, 2 times 4 plus 1 gives us a square root of 9, minus the square root of 4 is 2. So 3 minus 2 is 1, and the right side is 1. So here we have 2 solutions, and there are no extraneous solutions. So this completes our discussion of page 105.